It is important that you have a basic understanding of how GMAW works, as this will assist you to set up and to operate your equipment efficiently. As in any arc welding process, an electric arc is generated across a small gap between an electrode and the metal to be welded. In this process, the arc generates enough heat to cause local melting of the base metal and the electrode tip. In any GMAW process, the electrode, or filler wire, is fed continuously into the weld zone, or arc, where it melts, at the rate at which it is being fed into the weld pool. During the welding process, a shielding gas is forced via the nozzle of the welding gun, and this creates an invisible envelope, or shield, around the tip of the electrode wire and the weld pool. The shield effectively prevents the oxygen and nitrogen in the atmosphere from coming into contact with the molten metal, and this prevents contamination, or porosity, in the weld. Shielding gases used in MIG and MAG processes include argon, helium, and carbon dioxide. These gases may be used individually or mixed in various proportions. In contrast to MIG and MAG that utilize solid wire electrodes, the FCAW process utilizes hollow electrode wire. Within the hollow core is a mixture of substances, such as chemicals and powdered metal, known as flux. When a flux-cored electrode melts, the flux produces a cloud of gas which shields the weld zone. In this respect, flux-cored wire acts in a similar fashion to ordinary shielded metal arc or stick welding. The FCAW process is sometimes used in conjunction with a shielding gas. The gas used with FCAW is normally CO2, and its purpose is more to do with the weld property and gun cooling than it is for shielding. FCAW is commonly used in fabrication and structural work involving carbon steels, stainless steels, and cast irons. The type of shielding gas used in any GMAW process will affect certain factors, such as the shape and penetration of the weld bead, the speed at which filler material can be deposited, and the mode of metal transfer, a topic that we shall discuss in the next section.